like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Digital Engineering Implementation, Progress and Plans. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. And time permitting, your questions will be answered at the end of the session. The briefing slides and webinar recording will be posted on our website within a couple of days. And finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. My pleasure to introduce our presenter for today's webinar, Ms. Philomena Zimmerman. Phil is the Director for Engineering Tools and Environments within the DoD Office of the Deputy Director for Engineering. Her portfolio includes digital engineering, engineering infrastructure, CIO collaboration, along with model and simulation technical leadership. She supports elements of the OUSD R&E related to policy, practice, and workforce development, as well as the use of digital practices. As the lead for digital engineering, Phil works to advance the use of model-based techniques for engineering practice in all engineering and related activities for the DoD. I will now turn the presentation over to Ms. Zimmerman. Good morning, Phil. The floor is now yours.
Good morning, and thanks, Steve. I want to thank CSIAC for inviting me to talk to everybody today about digital engineering. I'm actually humbled to be here. When we embarked on this, what seems like a very long time ago, we just couldn't have even imagined the impact that a simple statement like be able to do everything in a computer would have. And so, I thought I would talk to you a little bit about where we are progress-wise and where we need to go. But I think in order to do that, we need to set the stage on where we came from because it's very relevant. And it's at the end of this talk, if you're still skeptical about whether or not you're doing digital engineering, that you're going to say, wait a minute, I already do that. So maybe I'm already on my way, and I hope that's the case. So Steve, if you could go to the next slide, please. I want to talk about why digital engineering is important and where it came from. And I want to talk to people that the digital strategy that we produced and Dr. Griffin signed in 2018 is really more than just buying the right tools. I have a statement that said even a fool with a tool is still a fool. Certainly that doesn't apply to anybody on this call, but you really do have to think about how to apply these. And perhaps that's the real crux of the matter with digital engineering is that it's not going to help you to be a better systems engineer. As a matter of fact, if you're bad at systems engineer, it's probably going to prove that you're bad faster. But you really do have to think, right? That this isn't a substitute for not having to think about what we want to do. I want to talk about digital engineering as it relates to some of our larger engineering efforts that we have ongoing in R&E. And then what are we doing to help further this? So Steve, if you could go to the next slide, please. Many of you have seen this already. This R&E mission was crafted from the National Defense Strategy that was released by Secretary Mattis, and everything that we've seen so far from Secretary Austin says that we're continuing in the same vein. And more importantly, I want to talk to the areas where we're going to bolster modernization, support to new pathways, as well as accelerating capabilities to the warfighter. And we really feel that acceleration is possible in the way we engineer our systems if we learn to take advantage, where practical, of what the increased rigor will get us. And there are a couple of fallacies, right? Digital engineering is not going to save you money. It might not actually cost you any more money either, though, but it will allow the funds to be appropriately spent where there are things that we cannot yet model, and I hope to get into that as we go forward. Next slide, please. So where did we come from? In 2010, Ms. Kristen Baldwin, who was then the acquisition modeling and simulation executive for the department, when we were still one acquisition technology and logistics, or AT&L organization, asked a gentleman who, I don't know if anybody on the phone knows him, Mr. Del Lunsford, who was the director for Army modeling and simulation before he retired, in his retirement time, to just postulate what a future of modeling and simulation might look like. And we called it the summer study, and we took it in 2010. And some of the things that came out of that study, remember, this was just about modeling and simulation. Digital engineering wasn't even a term at that point. And some of the things that are pertinent are still pertinent today, right? I think about digital engineering, I'm rethinking what model really means. And I'll talk a little bit about that in just a couple slides. The techniques and tools tend to be created within the organization themselves, but rarely shared. And that's an important hurdle for us to overcome. And I'll talk a little bit about that. And there is this linkage between virtual simulations and high fidelity physics models that at the time were something we postulated on, but today, with the advent of advanced computing, is really something that we believe we can take advantage of today. But we've got some hurdles to overcome. This is a forward-moving item, digital engineering is. There is no sign of it turning around. There is no sign of it going out of fashion or not being a trend anymore. But I'm going to tell you, I think the reason is because we don't care what it's called, right? What we care about is the proper use of these computational tools that we have in front of us to help us do our engineering job. And I'll let you read the rest of it. Steve, if you can go to the next slide. This is actually a picture from that summer study where in the upper left, it was, let me think about what I need. And in the lower right, it was, let me push a button and get what I need. And so you can just imagine in the over 10 years that we've been on this journey, you can see the pieces that have come to light, and now we seek to connect them, right? So my favorite one is additive manufacturing, or actually subtractive manufacturing. Many people don't think about the term additive, where you're piling layer upon layer of things, but subtractive manufacturing, where you're, say, cutting out the windows of a fuselage. All of those, most of those are CNC machines, right? They're numerically controlled. They're controlled by a computer. That gets us in the right frame. And so you can see as you walk through these arrows here that we've come up with different techniques along the way, and digital engineering seeks to help people understand that now not only can we, but we must put that flow together. And the reason that we must put the flow together is because the reality of the rigor that we seek to bring in engineering is about sharing and evolving the data and models as we go forward, not using them for what we need to use them for, put them on a bow, put them on the shelf, and start over again when you go to the next phase, right? That's not really the way this should happen, and that we're going to be farther ahead if we can learn to connect them. I'm not going to use the word integrate because I really think integration is almost a holy grail, personal opinion. But if we can connect these in a way that allow us to take advantage of the rigor that went from the step before and provide rigor to the step that happens afterwards. So Steve, if you can go on to the next slide. This is one of the things that I talked about. And Steve, I don't know if it builds in Adobe PDF, but if you could just build it out, I would appreciate it while I talk. Modeling and simulation is where we started from, right? The summer study was all about, remember, rethinking the M in M&S. What I want to point you to is the blue block in the middle, right? This is the definition of a model. It isn't any more than that, right? And so there's a famous Einstein quote that I'm probably going to butcher, but that is one of my favorite ones, that said, anybody can make things more complex, but it takes perseverance and a real touch of genius to make things simpler. And this is as simple as it gets. I want you to think about this. If you take nothing else from this briefing, remember this: a model is just a representation of reality. It doesn't talk about size. It doesn't talk about validity. It doesn't talk about risk of use, any of those VV&A things. It doesn't even talk about an application, just the thing. And so I like to point out to people that if anybody is familiar, and I don't know if it's still in vogue anymore, Earth-centered, Earth-fixed coordinates, 0, 0, 0 is the center of the Earth. It always has been. It always will be. It's a triplet. Or you can have a representation of the outer mold lines of the wing of an aircraft, which is a very different data set, but they are both models in this definition. And that's where we draw our power from. Modeling and simulation used to have a coordination office. They no longer have the coordination office. Last year, that was moved into the group that I lead, Engineering Tools and Environments. And now modeling and simulation is taking back the technical leadership role for those foundational elements of modeling and simulation, right? What does VV&A look like to the entire user community? And remember, now the user community includes everybody who's a digital engineer. And if I was briefing this in person, I would do the following. So you don't have to raise your hand, but let me give you the story. Usually what I do is I ask people, have you ever produced and used an Excel spreadsheet? And usually, if I don't get 100%, I get at least 75% of the people will admit to doing it, right? Myself included. My answer is, congratulations, you're a digital engineer, right? It really is that simple. And that spreadsheet is a model of something. Could be a model of my budget, could be a model of the steps I need to take to remodel my house. All of those things I actually have done practically with Excel. It could be the schedule for my project. It could be the classes I have to take to get my graduate degree. It's just a model. And so that becomes very important. There are baseline things that happen in that the modeling simulation community needs to have happen to make them usable. Validation, verification, and accreditation is one of them, right? Is my model suitable for use? That same question gets asked in digital engineering, right? Can I use this representation in this analysis? Can I use this representation in this evaluation? The main difference is that digital engineering evolved from looking at how the user wants to use the artifacts and drawing the needs and requirements from there. So it's almost just a different viewpoint. That viewpoint has caused the digital engineering community to care very much about what's important to that particular community, be them analysts, be them cost estimators, budgeting people, schedule people, and IMS, for those of you who are on the phone who have ever looked at them, is just a representation of what you want your progress to look like. All of those should be valid, should be suitable for use. So digital engineering took a look from the user perspective, and I think it was much needed in the modeling and simulation community. But that causes some challenges for us, right? So modeling and simulation has VV&A. Digital engineering needs to have a level of trust. Are they the same thing? Well, no. Validation and verification contribute to the levels of trust, but we believe that there are other things that are important. There is a risk of use, which actually happens in both modeling and simulation and digital engineering. So there's more common than there is different. And that was one of the reasons for moving the modeling and simulation effort into engineering tools and environments. So we can take advantage of the very rich set of practices that occur in the modeling and simulation community and add to them or qualify them by what the user needs. So we think this is not quite a match made in heaven, but it's really close. Steve, if you can go on to the next slide. So I've been talking a lot about what digital engineering is, and some of you actually may not know. I actually ran into somebody the other day who didn't know what it was, and I'm always amused by that because it's just an opportunity for people to open people's minds and get very simple with them. And so let's talk a little bit about the digital engineering strategy. Digital engineering strategy was written in 2018. Nope, don't ask me the question. I have no intention to update it because I don't really think it needs to be updated. It's very simple. You can find it on our CTO website, www.cto.mil, I believe. If you look for under engineering and root around a little bit, you'll find it. But it contains these are the 5 elements of it. And so I'll paraphrase them. I'm actually kind of doing it with my eyes closed. The first one says that if you're going to use models, you need to tell people you're going to use models. Well, that seems intuitively obvious when you say it, but it's actually a lot harder than it sounds. How to convince people to shift from doing things with stubby pencils into doing things that you might enter through a keyboard. Turns out to be a bit of a cultural challenge and a bit of a tool challenge. Do I have the tools that will enable me to do this? And how do I get my intuition out of a tool? Because a lot of what we do in engineering, when we do not understand the phenomenology to be modeled, we cannot put it in the computer. We guess, right? Educated guesses, wags, whatever you want to call them. And we don't necessarily know how to put those into our computational space, although I'm hoping AI and machine learning can help us with that. But it says if you're going to use models, if you're going to do models, you have to tell people you're going to do that, right? That puts people in a different mindset, so that's very important. The second one says that you need to have something that we call an authoritative source of truth. And so there's nothing in here that says single, at least there shouldn't be. There's nothing in here that says it has to be all in the same format, although I would recommend it. But it does say that if you're going to do these engineering tasks that you have, whatever they are, costing tasks, training tasks, you need to understand what ground truth is to you and to what you are trying to achieve. So I might offer that if you have such as a system design model for something that you're trying to build, that might serve as part of or all of your authoritative source of truth. If I'm trying to manufacture the wing of an aircraft, then the outer mold lines and the thicknesses and all the physical properties of it become my authoritative source of truth. But how that wing behaves under high stress environments might not be part of the authoritative source of truth I am going to care about if I'm manufacturing it. Might not be. I'm not a manufacturing guy. Please don't send me hate mail. My point is this. The authoritative source of truth is composed of a lot of viewpoint truths. And we need, all of those have to come together in order to have that representation of whatever it is you're trying to build. The third one says that we have to be innovative in looking at new techniques, such as I talked about AI, ML, to help me understand intuition, right? We should be open to that, especially if we can put it in a computer, right? That's what this is. This is all about that computational space and doing things in it. The fourth one is my favorite one to brief because it almost didn't make it into the strategy. You would think that if you were talking to people about doing things digitally, that they would just know they have to have a computational space to do it in. It turns out that's not true. And so this one got added against my wishes. I was proven wrong many times. I've had a number of people come up to me and say, that's actually the most important thing you can tell people. And we've had some advances in that area, and I'll talk about those in a minute. And then the fifth one says you need to transform the culture and workforce, right? Not everybody needs to know how to model, but everybody needs to be comfortable working in a digital environment. And digital just implies modeling. Steve, if you could go to the next slide, please. I think 2 years ago, there was a Defense Science Board study called Gaming, Experimentation, Modeling, and Simulation that actually had quite a bit on digital engineering in here. And so not my definition, their definition of digital engineering probably brings me to the next thing, right? Which is it's automation applied to a rigorous definition of system elements. And you need to get simple here. It doesn't say what type of system. It doesn't say physical system. It could be an accounting system. It could be a policy system, right? It's a system. Digital engineer. Here's the nice thing about working on a computer. The computer doesn't care. It doesn't have feelings, right? It doesn't care how you apply the data. And that's actually part of the danger. We need to be as rigorous as we are expecting to benefit from the rigor that comes from computation. But anyway, so it's a larger study. It was a DSB study. They completed it. I think they're getting their final report cleared for public release. It will be on DTIC, which is a good thing for the audience that pays attention to the IACs. But anyway, I'll let you read some of what they have here. Go to the next slide. This is actually kind of fun. If you take, I haven't done this yet, but if you take this slide and you compare it against that slide from the summer study, I'll bet you there's a lot of similarities in them, right? So that means that we haven't quite fulfilled our imagination yet, and we need to get creative, and that's what we're going to do. That's what we're going to do with digital engineering. So Steve, if you could go one more slide, the digital engineering framework for communication. And this is the must part of what I said earlier. We must learn to communicate through the digital artifacts that we have that describe our systems. We must. This is no longer about the written word. The written word certainly adds interpretation and it adds intuition and all those wonderful things. But we cannot compute on the written word. We compute on value. We compute on steps, right? Those are the things that enable us. These are enablers for engineering. They aren't going to replace the written word. Please don't go back to Miss Cummings and A&S and tell her that digital engineering is going to revolutionize. You never, ever again have to read a spec, right? I'm not promising that, but I am advocating that at least in the meantime, we buoy what we have written word with what we can do computationally. We have all of this wonderful computational power at our disposal. I have 5 computers in my house, right? It's just my husband and I. Don't ask me anything more about that. But I have 5 various computational devices, right? I have access through the internet, through VPN, to the high-performance computing modernization platforms. You only have to open up the front page of the Washington Post to understand that cloud is going to become available to us, right? The CIO is working on new tools that they're going to distribute to everybody. There's an incredible amount of computational capability at our fingertips. And there is one more thing that comes with it that we must learn to take advantage of. And that is the ability to share, discover, access, and reuse those digital artifacts that we have, right? Remember, the data doesn't care. That's part of the problem. We need to be able to discover, access, and reuse as part of digital engineering with the appropriate understanding of what the data and algorithms and process steps that we have were originally intended for. Doesn't mean you can't use them for anything else. I wear a shoe. Actually, I wear 2 of them. But I wear a shoe, but I can use it to pound a nail into the wall. It drives my husband crazy. But there are things that we have that the only reason that's stopping us from reuse is that we can't get at them, right? That seems silly in today's environment. So we have, again, a lot more cultural things, but that ability to discover, access, and reuse becomes the framework for communication. We often talk through that the authoritative source of truth that I described to you a little while ago actually is the mechanism for communication between engineering disciplines. One is one is one. It doesn't change except in how that number is used. So if I have 1 volt from some electrical calculation I might have done, that 1 volt needs to be transmitted to my thermal engineer, perhaps. If my piping is 1 inch to go through, I don't know, a deck plate, it sounds like a bad idea, but if I need a 1-inch hole to go through a deck plate, my structural engineer knows that I need to have that 1-inch hole, right? They don't change when we butt the engineering disciplines up to each other. We need to communicate through this authoritative source of truth. And so if you go to the next slide, Steve, let's talk a little. So now you know where we came from. Now you know how simple this is, right? Simple to talk about, hard to practice. Let's talk about digital engineering and practice. And so what are we at the OSD level doing? And so I want to remind everybody, often, because I get asked the question, well, if I'm an acquisition person, the acquisition policy, at least at the time I was asked the question, it doesn't say I can do this. Well, you're right. It also doesn't say you can't do this. Okay, so again, just a different perspective. Bill, is OSD going to put out a policy? And I often ask people to stop and say, do you realize what you just asked me? Do you want me to tell you that you have to do this? Well, okay, I suppose I can. But that policy is likely to come away with other baggage, right? And we didn't choose to do that. We put out the strategy, we put out the goals, we worked with the service partners and one of our R&E agencies, MDA. That group continues to do digital engineering work, but the implementation should really be up to the user communities. And so we have been working very diligently with our services to help them with their implementation. From an acquisition standpoint, that's where most of the programs reside. That's where most of the budget resides. That's where all of the schedule pressures are. So we really believe that the implementers in digital engineering need to be responsible to both what they have to do, you know, in law and in regulation and in policy, but also need to be given the latitude to take advantage of this idea. I can't even call it a new idea. I mean, you saw from the 2010 summer study, it's been around for a while. You need to do this in a way that makes sense to you, in a time frame that makes sense to you. And we're trying to assure people that this is not something you should be afraid of, right? This is not a new technique that's going to cause you to abandon everything you have ever done, nor is it a technique that's going to instantly make you a genius. But what it is going to do is it's going to supply you additional rigor and additional certainty so that you can take the resources, people, time, money, and apply them to areas that perhaps we're not as good at modeling or we do not yet understand the phenomenology. It's about appropriately placing the resources. I should say that's one of the benefits of it. We want to make sure that we don't talk about cost savings. We actually talk about cost avoidance. And so there are wordsmithing maybe? No, I don't think so. I mean, we really have thought about this. So we're driving implementation by helping, right? The digital engineering strategy tells you what, not how. We're having enormous breakthroughs in the how, in the realization from Goal 4 perhaps, that you need to have this infrastructure. Steve mentioned to you that I had this task, connect the engineering community, right? What do I have available to me that is already paid for? For those of you who are testers, I would offer you TRMC and their capabilities, right? Those are already paid for capabilities. They are for the test community, but just like I said before, that is a particular application. They have tools that, for lack of a better word, schlep data around. Well, I'm a mechanical engineer. I need to have my data schlepped. but I use those same tools. And so we spend a lot of time in the implementation helping people understand that you need to separate the tool, the hammer or the shoe from the application that it's in. And when you speak about the tool, speak about just the tool and its capabilities, and don't get wrapped around the axle when it's applied to a particular area. Those are some of the things that we do. Gaining leadership commitment. I had some members of the senior staff and R&E come back to me and remind me that when I'm doing this Connect the Engineering Community, that I need to pay attention to the fact that it's going to cost money, and so I need to be aware of that and alert them as soon as I can discern some costs. Which is the first time I've ever been asked to put budget money in for things that in the past have been not wanted to be discussed because they weren't as important at the time, or perhaps not as much fun to talk about as the new missile that I'm creating. Leadership now has a focus on these baseline foundational computational spaces need to be made available. And they understand without grimace, at least my experience is, without grimace or without grimacing, that this is going to cost money and the investment needs to be made. And so I think that that's an awesome sign of leadership commitment. Engage the workforce, right? Hopefully I have some people who have never heard me talk before, or else you're falling asleep during this one, because my message doesn't change. But engaging the workforce is what I do. I had an opportunity to speak to the senior cadet class at the Air Force Academy to talk about digital engineering. Again, it's just how do we keep, if I don't talk to you and then take a minute to listen to what you are saying, I cannot advance digital engineering in a way that is meaningful to you. So engagement is not just one way, it is two-way, and there will be time for questions at the end. I might not like the answers, I might not have the answers, but it is about an engagement, and engagement is two-way, right? What do you need? When digital engineering, when we started down this path, I had just come off of the Army Future Combat Systems, and I knew as the Director of Modeling and Simulation, I was making a lot of demands in the modeling and simulation community, and I wasn't getting help. Now that I was in the modeling and simulation community at the OUSD level, I realized I wasn't hearing anybody's demands, and so it was a communications problem. So we're big on two-way engagement. Resource allocation, I spoke a little bit about it with Connect the Engineering Community. This is, do we have to train people? Perhaps, right? I think you need to evaluate them. I just sat through a briefing yesterday from the Air Force, Mr. Steve Turek. I think he's at AFRL, about digital engineering or digital maturation, right? How do you know that you're competent? And he's got some really great ideas we're hoping to bring forward, and they've got some really nice ways to assess it. There's a capability maturity matrix, right? And it doesn't tell you how much you need to spend to go from maturity level 1 to maturity level 2, but it does tell you the things to look at, right? And there's a wealth of support out there in terms of classes and bodies of knowledge, et cetera, et cetera. I'll talk about that in a minute. And then we want to measure results. I don't want to measure results of the number of people that have been trained. I've been trained in how to model, right? I took a class. I know how to do it, but I'm not very effective at it because I don't practice it. So what we really care is how effective are these techniques in doing what we need to do. That's another part of engagement. What do you need to be done, right? How do we get this? How do we get this communication? How do we keep it going? And then more importantly, and if there's anybody on from a tool vendor, I don't think I've changed this message either. If we as users of tools do nothing more than use the tools as they are provided to us when we pay for them, and in some cases pay heavily, then we have lost part of the promise of working things in a computer and part of the creativity. We have to not only open the dialogue with each other, but we have to open the dialogue with our tool vendors. We know what our job is. We should have that dialogue with our tool vendors so that our tool vendors can provide us the tools to help us do the job that we need to do. It's lucrative for them. It's better for us. And so I want to measure the results. I'm not measuring results of tools. That's not my job. But I do want to measure the results of the effectivity here and look at where we need to advance. Steve, if you can go to the next chart, please. Here's kind of a summary of what I've talked about. The Dr. Griffin quote for the strategy is on the left, right? On the right, and so in the middle is, where we've collaborated. And we, NASA, Veterans Administration, FAA, all of the services, the agencies, PNR, ANS. We don't own there's no copyright on any of this. Model-based system engineering through the standards, open group, object management group, the model-based system engineering work out of NCOSI. This is all in the public domain. We care about working those particular very foundational capabilities to the benefit of the Department of Defense, and that's where our part comes in. But we're going to learn more from collaborating. And so what I want to focus on here is the collaboration activities on the right-hand side. I lead a digital engineering working group that we are trying to turn into a larger community of practice. And so that involves opening up all of our work to industry and academia, which is easy to say and certainly a desirement, but really hard to do when you work for the Department of Defense. And it has nothing, that's not a negative statement. It's just we have things that we cannot share for very good reasons. And we need to make sure we can detangle those, right? And so, so we are doing that. The meetings are quarterly. My contact information is at the end. I assume you can contact Steve and he can put you in touch with me, whatever, but we'll get you connected. We'll get you on the invite list. About 100 to 250 people, depending upon the topics. But we're trying to turn this into a community that is responsible to itself. The community brings a problem forward and we put a team together to fix it. We, the community. And so that's what I refer to as Tiger Teams here. I have a number of them that are ongoing right now. I have one on infrastructure. I have one on implementation, which is searching far and wide for the best practices. One on cybersecurity. We have one on data, and I have one on building the body of knowledge. And I say I shouldn't say I, the community. See, it's a cultural change even for me. The community has these. Some of them, and these Tiger Teams aren't very large, but every one of them is led by somebody who has to do this job in their day job for their particular service anyway. So, for example, Lisa Fitzgerald she has a data job for the United States Air Force, and she's leading the Data Tiger Team. And so you open your aperture just a little bit, and you get a lot more benefit and a lot more support. Systems Engineering Research Center is, I think at last count they were 22. It's a UARC. It is the baseline keep the lights on money comes from R&E, but they do a tremendous amount of work in digital engineering itself, as well as application of digital techniques into different activities in different domains. So that's another place you can look. I already mentioned NCOSI and NDIA. I probably didn't mention NDIA, but those are partners with us, both professional society and an industrial association that we work very closely with. And together, all three of us have a digital engineering information exchange working group, the DEXWIG, as it is fondly known, that is actually led by Sean McGurvey from Johns Hopkins, and it has Raytheon and Northrop Grumman and Boeing and Lockheed Martin, I think, on the leadership team as well, and probably a few other people. And they meet monthly, and they meet at every NDIA, every NCOSI international workshop, and an international symposium. And they are there to help understand, to present the different things that we need to consider and benefit from in exchanging this information about our systems, this authoritative source of truth, digitally. By working through NCOSI and NDIA, we have this wonderful ability to bring in best practices from industry, and best practices from industry that aren't necessarily defense related. And so that it's actually been quite a benefit to us to get other ideas in. And we're very happy to be the government liaison to this. I'm very happy to be the government liaison. There's really talented people who didn't necessarily come up through the ranks thinking about writing a document to convey a requirement. They actually understand what it means to do it in a model. And so it's really an energizing group to be with. And I would point you to that. We're also revising the workforce. Digital engineering is a big part of the engineering revision to the acquisition workforce. We're building a body of knowledge. I talked about that with the Tiger team. And I also talked about aligning the understanding between modeling and simulation and digital engineering. Steve, you can skip the next slide. And if you just go to the summary and next steps, please. Hopefully by now you can see that we're driving digital engineering transformation by focusing on implementation. Digital engineering transformation is one element of a digital transformation or digital modernization. You may have heard that coming out of the CIO. We're very much tied into that. Do not confuse them. They are not the same thing. My job in life is hard enough looking at just engineering practice. But we want to drive it from what people need to do, not what we think they need to do, right? So we're always looking for guinea pigs. We're always looking for people who have tried things. We want to change this digital engineering working group into a larger community of practice. It's hard. I spent 40 years working for the Department of Defense, both as a contractor and as a government guy, right? I have muscle memory and ingrained practices that I need to change. And we have to have digital practices. You have to have the ecosystem, and you have to have the decision makers willing to accept and understand these digital artifacts and engineer things with perhaps different tools. And we have all three of those today. So now is the time, and I don't see this going away. With that, Steve, I will turn it back over to you for questions. And thanks, everybody, for listening.
Okay, thank you, Phil. That was an excellent presentation. A lot of great information in there, and a very I think a very important program. So if folks have questions, you can shoot them over here while we've got Phil, but we'll get the ball rolling. So I'm curious about the workforce development. So do you have some thoughts on how we might be able to go about transforming the workforce to be more capable in this new digital world and work in this type of environment?
Yeah, that's an excellent question. It really speaks to the cultural challenges we have. It's not an age thing, although we tend to think of it like that, right? So those of us who are older engineers certainly are not going to want to learn how to model, right? And if I take my older in quotes engineer, and I won't tell you how old I am, but I do have a countdown clock for retirement. But if I take my older engineer and I teach them how to model, all I'm going to do is frustrate them. Well, that's probably true. And so what we've found in best practices is that those people who want to learn how to model should certainly be given the opportunity to do that. I did take a modeling class. I found it fascinating to see the embodiment of what we believed to be true, but it turns out I'm not very good at modeling. Just because I don't practice it every day. So my advice to people who are looking to transform their workforce is don't force people to do what you want to do, right? That doesn't work in any situation. But if you have people that want to learn how to model, by all means, I think you should teach them. I think you should teach them to the skill level for what they need to do. For example, if you really do have an engineer who really does not want to learn how to model, then don't force them to, but pair them with someone who knows how to model. Typically, we talk about those as like somebody fresh out of college. But somebody who does know how to model, but perhaps doesn't have the domain expertise that the other engineer who doesn't want to learn how to model has. just watching the communication, the engineer who doesn't want to learn how to model speaks, the engineer who knows how to model types, this wonderful, literally before their very eyes, a model comes up, and the engineer who doesn't want to learn how to model gets to see in reality what they've actually known to be true all their lives, but maybe haven't taken the time to write down. You do two things. The engineer who doesn't want to learn how to model gains a comfort level. The engineer who doesn't understand the domain gains some domain knowledge. And most importantly, where we are now with an aging workforce is that you have now also captured some domain knowledge. And so I would offer that you do that. And I would also offer, don't overtrain your engineers. If you have an engineer who just knows how to read a model to verify requirements, maybe you need to send them to a requirements writing class and a real quick, a lesson on how to read SysML 2.0. And that's all. They don't need to be schooled in any tools. They don't need to understand the difference or the similarity between an architecture and a model. Think about what they do and then give them the right level of training to do it. Hope that answers that question, Steve.
Yeah, that's great, Phil. Thank you. So we've got some various questions coming in. So one person has talked about the making a comparison with what's going on over in agile software practices, kind of DevSecOps, with the continuous integration, continuous development, tool changes that kind of helped usher in that activity in the software arena. And the individual is wondering if you see tools that may be filling the same role to help with digital engineering, and if yes, what might the orchestration look like for the digital engineering process?
So that's an interesting question. I've never been asked that one before. So offhand, I don't see anything happening with automation, with tool automation to help with digital engineering in the basic sense, right? So, but I'm sure there are plenty of tool vendors if they're on the phone that would be happy to contact you. Where I do see the automation happening, though, is being able to use digital techniques to automate perhaps software testing, right? Section 231 of the FY20 NDAA talks about automated testing and automated distribution of software in a digital environment. So I see more automation in the application of digital techniques to particular activities. And that just makes sense, right? If I can quickly turn on software, I'm doing it in a computational space, right? I'm doing it in a computer. If I have engineering artifacts and activities that are digital in nature, I ought to be able to connect the two. So it makes sense to see that. I see a lot, especially in like I said, in software testing and in automated requirements testing. Those are the first places I've seen it, but I'm sure it's occurring elsewhere. The other thing that I see happening that I don't think we're too far off if it's from having it widespread is to look at things like logistics and sustainment areas in the Department of Defense, where and this is a big if I am accurately capturing the changes and upgrades and oil changes that I'm making to my vehicle, then I ought to be able to do some prognostics as to when might it come in again, when might the airplane go back into phase, when might I have to change the oil in my, Abrams and things like that. That implies, though, that you are accurately capturing the data at the time that the changes are made. If we can that's a problem. That's not a digital engineering problem, but digital engineering will rely on that. So yes, I'm seeing it in areas, but I haven't looked for anything with the basics of digital engineering? That's a great question. Thank you for that.
Thanks for fielding that, Phil. So we've got a couple different, a couple questions that are, addressing the current culture and, some problems that the current culture may have in the adoption, implementation of digital engineering. And so wondering if you have, if you've seen, what do you think are the biggest barriers to culture change, and what do you have some suggestions, ways to overcome those cultural barriers?
Yeah, I have seen them. I actually love this question because it's a question that demonstrates there's very little technical challenges that we have in digital engineering adoption. There's a whole bunch of cultural changes, right? I talked about money, which I tend to put in the cultural thing. People just don't want to spend money on it. But one of the things that I often ask people to think about is when you're trying to overcome moving from non-digital into a digital, I call them digital ecosystems, digital environments, computational spaces, whatever you want to do it, is to stop thinking that it's something new. And the spreadsheet example that I walked everybody through earlier is one of those areas where people may be already working in a digital environment or be in a digital culture, but they don't call it that. They call it Excel spreadsheet, or they call it M&S, or they call it automated requirements testing, that are digital in nature, but because it doesn't bear the moniker of digital engineering, people tend to think it's something different. This is not new, right? I talk about I talk about things that begin with the letter C, right? What digital engineering gives you, if you take advantage of it, is cohesion in understanding your representations, right? Now I don't need to fat finger in numbers from a paper report. I can just send the numbers, right? My favorite example of this is the printing of drawings, right? Most drawings get printed from a 3D model, and then some poor company gets the package of drawings, and then they get 2D drawings, and the only reason they get to be 3D is because they're stacked on top of each other. That's a joke if you haven't figured it out by now. But and then you have to read them back in and recreate the 3D model. Well, that's just dumb, right? Why don't we just send the model? So there are things that people may already be doing that are recognized as digital, and sometimes you just need to call their attention to it. So my biggest piece of advice is don't think that this is new. Think instead about what newness you can bring. Cohesion is one, collaboration is another, communication is another. I think that's the biggest piece of advice. The second piece of advice I have is don't train anybody in doing something that they don't really want to learn, because that's just pointless. But those are the two big things I have. Start with what you already know. That's not, by the way, insightful. I apologize because that isn't stellar, but that's what I got.
That's great, Phil. No, thank you. We appreciate that. So we got another question regarding the workforce and workforce development. So individual is, basically saying that he's having trouble, attracting and retaining modelers just because of the great demand. And so, is there a way to address this where we can, increase the people with the capabilities in this area? Any way to, up the, the skill set there?
Yeah, that's another really good question. I don't have a great answer to that one, but I think if you look to the services, they're looking in that area. Probably 4 or 5 years ago, when Dr. LaPlante was the SAE for the Air Force, he talked about owning the technical baseline. And it turns out he didn't mean own all the data. What he really meant was fully understand that, which you were building. And Dr. LaPlante actually was on the GEM study that I talked about in my briefing. Because of that, the Air Force embarked on and I think it might have been, I don't know that it was a full DSB study, but they embarked on a study on what does it take to retain and grow your organic engineering workforce. So I would encourage you to search on that, because I think they had some very salient and, again, very simple characteristics. And the one ideas, the one that I remember the most was, if you want to attract a digital workforce, you have to allow them to work digitally when they get here. Another one of those aha moments. But for example, I work digital engineering and I don't have a modeling tool on my tablet for all the wrong reasons, right? It has nothing to do with willingness of my leadership at all. But if you want to attract the talent, you have to give them the jobs that will allow them to utilize what attracted them in the first place. And being able to model things in a computer turns out to be a very attractive skill set for the people who are graduating from school now, right? They're taught to do it in school. They want to do it when they get into their job. That's why they stay in these jobs. And so I would offer to just make sure that when you're attracting them, you actually do pair them up with what you want them to do. Again, I would turn to the services for that one, and I would especially look for that organic engineering workforce report from the Air Force.
Thanks for that reference, Phil. That's excellent. So, kind of regarding the environment. One of our attendees is wondering if the government will be developing or adopting any data interface standards. The industry may be able to use different tools other than what the government's using, but still be able to deliver compatible model data. Do you see work going on in the standards area?
I do, actually. And again, not as outlandish or not as awe-inspiring as you might think, but there's plenty of data standards out there. I would recommend that we don't invent a new one. The biggest move that I saw happen was in both the DODAF and I think in SysML 2.0 was that they separated the data model from the underlying standard, which I think becomes very important. And so take a look at the data standards that are already out there before you think you have to invent another one. The next piece of advice I have is make sure that you evaluate the data standard or evaluate the creation of a new data standard from the viewpoint in which you want to use the data, right? I used to be the high-level architecture program manager, and I got a call from a group down at Pax River that wanted to use the high-level architecture to schlep data on their operational aircraft. And they asked me if they could, and I'm like, well, you can do anything you want with the high-level architecture, but you have to know that I didn't build it for that, right? So you need to evaluate it from the use. And then the third thing is, and perhaps this is where it's worth a debate at some point in the future. I think interoperability of data formats and interoperability of tools is a holy grail that maybe we ought to just stop going after. And what I mean by that is the following. We do everything that we can, and every bit of looking at digital engineering is to absolutely support the warfighter. I'm the mother of a soldier who's currently deployed. I totally understand the need to want to keep him and his unit safe. I'm not going to do anything that's going to take away from that, and we're trying to enhance that. But when it comes to my engineering job, and I don't say this lightly, there is nobody shooting at me, right? So if I need to take an extra millisecond or two to translate my data from one format to another in order to achieve interoperability, that might be the better solution. Again, everything comes with a risk. when I do that translation, is my translation lossless, or can I accommodate the loss in what I want to use the data for? So I think perhaps we need to shift our thinking a little bit. Now, if I were to interoperate simulations, which are just models executing over time, if I were to interoperate simulations because I needed to put a training scenario together where I had live participants, that's a different subject and a different application than if I want to understand the analytic consequences of putting a new missile into a mission. Very different applications, and we need to be very careful that we are looking at the problem correctly and solving the right problem rather than tilting at another windmill. Over.
Thanks, Phil. Yeah, that's awesome. Well, we're right about at the end of our time for today's webinar, and I want to thank you for the sharing your time, your expertise, and information with us. It was very, very informative, very enlightening presentation. And the response we got from our audience, with questions that came in today, definitely solidifies that statement I made.
All right. Well, I'm happy to do it. If there's any further questions that need to be answered, my contact information is in the briefing. Feel free to use it. I ask that you're patient, though, because I often have more emails to respond to than I have time in the day. So just be patient with my response. And likely our response in getting you an answer is going to be connecting you with somebody else in the environment. The wonderful thing about the digital engineering community is that we help each other, and you don't have to go through me or my office to get an answer. Over.
Okay, thanks, Phil. And so the one thing I will mention is that we have captured several questions that we just don't have time to get to today. But what we will do is those questions that did come in during the session, we will pass those along to you. And if there are questions you can answer, or if you want to direct them to somebody else. Now we can also So we can do this in a couple of ways. You can answer the questions directly, or we can, get the filter the answers back through CSIAC, and then we can post them onto the our tech channels, where we'll have your webinar posted, and that way folks can see the answers to those questions along with the briefing and the recording of your presentation. So we can explore that offline, but I'll just throw that out as a possibility. And so once again, thank you, Phil. And so once again, everybody, thanks for attending. And I'd just like to make a brief announcement for our upcoming webinar next month. And so that's going to be held on the 23rd of March, and we'll also be starting that one at 11 a.m. And the topic for that is going to be deep learning for RF target classification. So if that's of interest, we hope you can join us for that presentation. Thanks again, Phil, and everybody for attending. I hope everybody has a great day. Stay safe, and we'll see you in the future. Thank you. Goodbye.